Hey everybody, welcome to Mammoth Interactive's YouTube channel. First of all, I want to thank you for watching this video. And remember that this channel doesn't do Patreon. Instead, we sell our digital courses down below. And every single dollar that we get from the products you buy below goes into making more content. The best way to help out this channel and Mammoth Interactive is to subscribe to Mammoth Interactive's huge library of content. Get thousands of hours and hundreds of courses for a low price down below. We have a monthly option and a yearly option. Thanks for listening, and I'll see you in the video.
Hello everyone, and welcome back to our Core ML course. In this lecture, I'm going to be showing you how to set up our first project for analyzing and building with the natural language framework. This is going to be the first Core ML framework that we'll look at, and our first project is going to be to learn how to recognize the dominant language of a text. Let's go ahead and set up a new Xcode project. For that, open up Xcode and go to File, New, and select New Project. This is going to show a prompt for you to select the type of application you want to create. We are going to create an app, a regular app, the default selection. Click Next, and here you can enter a new product name. I'm going to call this Recognize Dominant Language. The interface should be storyboard, and the lifecycle UI kit, the language Swift. Click Next, and you can now save your project to a folder on your computer. Click Create in order to create and automatically save the project. And here the project has opened. Let me make it full screen for you. On our left-hand side, we have all of our files and our structure of the project. In the center here, we have whichever current file we have open, and on the right, we have the sidebar. Let's all navigate to our first page, known as viewcontroller.swift. Here is where we are going to be creating our application. We're going to be building out, for the setup, a label on an app. To create a new label, we're going to be actually making it programmatically. You could, of course, make a label with the storyboard, which means you are dragging and dropping elements onto your app, but we are going to be creating all of our elements programmatically for this project. All right, so let me zoom in here so you can see a bit better. We have all of our code, and I can remove the comments for now to make it a bit more clear here. Here in our new project, we're going to have to import not just but the default UI kit, but we're also going to have to import natural language. Natural language is the natural language framework of Core ML. And by importing natural language, we can use many different pre-built models that are part of the natural language framework. We could also make our own models with Create ML or with some other model creation tool like Python. We could create our own models and wrap them for Core ML. To start off, we're just going to be using the natural language framework's own different models because there are many powerful models that Xcode has actually built already, and they're open source, so we can use them. Let's go ahead and set up our project here in view_did_load. Right below the super call, let's make a new constant with the let keyword. The constant is going to be called a label, and this is going to be the label that will show on our app. To make a label, you can call the UI label class here. UI label is going to make a label on your app. A label is just a piece of text. We can set the frame of our label to be a CG rect, and we can set the X to 0 and the Y to 0. X and Y is the position of the label on the app. Then we can set the width of the label as well to something like 300 and the height to 30. This is setting up the frame of our label. We're going to be later on using this label in our project. In this label, we're going to show the dominant language of a piece of text. Because the natural language framework, it has a model that can recognize a language in a paragraph. And that is what we're going to be showing in this label. All right, let's go ahead and use this label now. We're going to set its center point to a new CG point. The X can be 150 and the Y can be 300 as the center of the label. Then let's set the label's text alignment to equal .center. You could also set more properties of the label. You can see all of them here. There are many different properties that you can set all programmatically, but this is enough for now. Following this, let's go ahead and test out our label by giving it some text. You can set the label's text property to a string like hello world. To actually add the label to your app, we have to call self, referring to the view controller of the app, and view, referring to the view of the app, and we call the function add subview. This is going to add an element to our app, and the element we want to add is the label. Now we can test out our code here. To test out the code, first let's change the simulator type at the very top here. The default is iPod Touch 7th generation, but let's change that to iPhone SE 2nd generation, a bit more relevant to today. After we've changed the simulator type, hit the big Run button in the top left corner, and this is going to pull up the simulator. You should get a notice that says build succeeded, which means your app will run without any errors, at least to start. If your build fails, it means you have an error message somewhere in the code you have to fix. So my simulator has opened. I just have to hide my full screen view here and show you the simulator. Here it is. This is the iPhone SE 2nd generation simulator. And I've just pulled it in full screen here. After a moment, we'll see the text hello appear in the label. Hello world, in fact. There it is. That is exactly what we expected to see. Hello world is the label that we created programmatically. This verifies that our project has been set up and our label is working. Now that we've set up the project, join me in the next lecture where we're going to start using our first natural language model. And this is a machine learning model that is going to recognize the dominant language of a text. I'll see you in the next lecture. Hello everyone, and welcome back to our Core ML course. In this lecture, we are going to be starting using our first natural language machine learning model, and that is going to be the language recognizer. This is a model pre-made by Xcode that can recognize the dominant language of a text. Previously, we set up our project. We set up a basic app. Now let's set up our model. In order to use our natural language framework, we imported it, which means we now have access to many different classes of models. Such as, for example, we can make a recognizer constant that uses what's known as the Nl language recognizer. There it is. We just instantiated a new object of the Nl language recognizer. Nl language recognizer, it is going to be able to recognize a language in a string. For this, we need some string of text. So let's make a variable that we're going to call our string, and we can put in some text inside the string, such as, for example, please detect the language in this sentence. Now we can call our recognizer and use its process string function. This is going to pass a string to the machine learning model. Let's paste in our string as the constant that we want to process. To store our result, we have to call our recognizer dot dominant language. This is going to return an NL language type that is the dominant language of whatever has been processed before. We can store this in a constant called result. And just like that, we have processed a string of text and we have gotten the dominant language in that text. To actually test this result, let's go ahead and use the label that we built earlier, and let's set its text to be the result. We do have to also map the result to get its raw value. Now, why do we have to do this mapping? Well, because the result currently is an NL language type. It's a natural language type. That means it's not a string. It's actually a type of language. And we can get the raw value of that object type, which is going to convert it to a string, which we can then put it into label.text. Now, for our label, we can then add it to the view with self.view.add subview, and we're adding the label, just as we did in the last lecture. We can also change the label's font size if we want it to be a bit bigger. We can take the label.font and take label.font.width size and change it to 50. This is going to take the existing label font and set its size to 50. Now, because we have re-added the label, we actually have to remove the label that we added in the previous lecture for testing. So we just have to remove these two lines where we already put a label. Otherwise, the two labels would be on top of each other, and we don't want that on our app. That would be very messy. All right, let's go ahead and hit run on our code, and in our app, we will see what language is in the string. I'm going to hit run in the top left-hand corner, and great, my build succeeded, which means I have no error messages that I need to attend to. Here is my simulator. I'm going to pull it open here and wait for it to load. It might take some time to load your simulator, but that is fine. Here goes our app, and look at that, we can now see EN on our screen. EN, that is the natural language English. It's not written as English, it's actually stored as EN. Japanese is stored as JA, for example, French FR, English EN. So this confirms EN is the English language. That means, guess what? That our app successfully ran. And our machine learning model, the NL language recognizer model, it successfully recognized the dominant language in our text. It looked like the font size was a bit too big, it kind of cut off, so let's change that to 40. And let's try again. Let's try on another language, how about? For example, we could try German, alles ist möglich, and I just have to add in NO, and sorry for my pronunciation to all our German students, but this is a German sentence and it means everything is possible. So let's go ahead and rerun our app and see if we can now recognize German. I am going to hit run again and do test number 2. All right, my build succeeded and I just have to pull open my simulator here. There it goes. And now I can wait for my simulator to open up the app, and now we should see the natural language for German. DE, that's right, that is the natural language symbol for German, which is great. That means that we successfully were able to recognize German. Now you may be wondering about an edge case. Well, what happens if we actually mix two languages together? Well, let's try that. Everything is possible in German, and then let's try anything is possible in English. So what will happen if we feed our machine learning model two languages at once? This should be interesting. Let's hit run and find out. We will see what our machine learning model decides to give us as the result if we have two different languages now. We have German DE and also English EN. Those are the two symbols for the natural languages stored by the natural language recognizer. All right, we get DE again. So after all, the model decided to detect DE, but it couldn't detect two languages. All right, and this has been how to recognize the dominant language in a piece of text. Join me in the next lecture where we're going to continue learning about the powerful machine learning models that you can use instantly thanks to CoreML's natural language framework. I will see you in the next lecture. Hello everyone and welcome back to our CoreML course. The next project we are going to build is a string tokenization project. We're going to learn how to use the natural language framework to perform string tokenization, which is traditionally a complex machine learning task. We can perform it quite easily thanks to CoreML. So let's go ahead and break down what is string tokenization before we actually build it hands-on. All right, well, natural language processing itself, before we can actually perform the processing of the data, we have to make sense of it because more than 80% of data is unstructured, and that means we have to clean up the data. And string tokenization is one part of cleaning up data so that we can actually process it. We use text mining and also natural language processing to make sense of our data before we can then feed it to a machine learning model. All right, so in order to solve a natural language processing problem, in order to clean your data, we are going to first do word tokenization. Then you can predict parts of speech for each token. Then you can perform text lemmatization in order to split words at appropriate locations. That way you can identify two words as one phrase, and identify and remove stop words, as well as then perform any other potential cleaning. This list is not a end-all be-all. So you can see here, in order to actually perform machine learning on text, there are quite a few steps you have to take to clean the data, because a lot of data is quite messy, as I'm sure you can predict from the internet. So because this data is messy, we have to clean it and prepare it for our machine learning models. Word tokenization is the first step of cleaning data. So what exactly is tokenization? Well, it is where you split a phrase, sentence, paragraph, or even a whole document into tokens. So instead of having a whole document to work with, you actually are going to split it so we can go word by word or phrase by phrase. A token is basically a smaller unit, and typically it is a word or a term that will typically be a token. Let me use an example to demonstrate how word tokenization is performed. Suppose we have a sentence, "This is a CoreML course," and suppose we want to process this sentence for machine learning. Well, before we can actually process the whole sentence, we often want to tokenize this sentence. We're tokenizing this string, and that means we are going to break it up into smaller units. We're going to break it up into tokens. So by the end of processing this string, we would have 5 tokens instead of 1 string. And that is how we can perform step 1 of cleaning our data. Cleaning data is very important because, as we mentioned at the beginning of this lecture, 80% of all data out there is unstructured, and that means there's a lot of cleaning that has to be done. Let's actually jump into a hands-on project of word tokenization in the next lecture. We are going to jump into Xcode and build out some string tokenization quite easily thanks to CoreML. In this lecture, you learn that string tokenization is an important part of the machine learning process because it is up there at the beginning of your machine learning process. You have to clean your data, and one part of that is string tokenization. I hope to see you in the next lecture where we are going to jump into Xcode. Hello everyone, and welcome back to our Core ML course. In this lecture, we're going to learn how to use another machine learning model, part of the natural language framework, and that is going to be the model that will tokenize a string. For this project, let's make a brand new Xcode project. We'll go to File, New, Project. We are going to make a new app, and we can call this Tokenize String. Click Next to save your project, and click Create to create the project. Alright, we can also make our screen full screen, and if you click on the very top leftmost icon, it's actually going to hide the navigation for you. And if you click on the rightmost icon, that is going to hide the inspector. Let's all go to viewcontroller.swift. Here is where we are going to write the code for our app. We can also hide the navigation now because we'll be sticking to this file. Alright, let's go ahead and get started. Because we're using the natural language framework part of Core ML, we have to import natural language. Following that, we can then instantiate one machine learning model that is part of the natural language framework. That machine learning model is known as the Nl Tokenizer. The Nl Tokenizer can create a token from a string, and many tokens from a string if there are multiple words. We have to pass in the unit, which is going to be word, because we are tokenizing words in a string. Then let's make a constant to store the machine learning model object. We'll call this our tokenizer. Alright, so we have instantiated the machine learning model, which means we can now use it. But we have to use it on some piece of text. So let's make some text that we want to tokenize. We'll make a variable called text, and let's put in a string like, for example, a random paragraph that says, once upon a time, there was a student watching a Core ML course. They went on to do great things. Alright, so this is a paragraph that we can now tokenize. And let me show you how we'll do that using our Nl Tokenizer. It really doesn't take many lines of code. The first step is going to be to take the tokenizer and set its string property. We set its string property to the text because we have to tell the tokenizer this is the text that I need to tokenize. After that, we are going to use the tokenizer enumerate tokens. This is going to allow us to iterate through all the tokens that the tokenizer created. The tokenizer is going to go word by word and assign a token to each word. We have to pass in several properties here. We have to enumerate in our text.startIndex all the way up to our text.endIndex. So what we're doing here is we are setting the range of the enumeration. We're telling the tokenizer to enumerate from the beginning of the text to the end of the text. Next, we open up curly brackets to actually create the body of the enumeration. And in the body here, we're going to make a token range, and we'll say in the token range, we'll print out the text at the token range. This is going to allow us to get each word. And following this, we also can return true. And just like that, we are going to tokenize all of these strings. The best way to understand this is to run it. And because we are printing here, that means we're printing to the console. We're not making a label in an app. You could put the results here to different labels on your app if you wanted to, but to keep things straightforward and to really focus on Core ML, we're just going to print it to the console for now. To run the console, we don't just hit the big run button. We actually go to our header here, the Apple header, and we go to View, debug area, and we click on Activate Console. And this console is going to pop up at the footer of your project. Now if we hit the big Run button, we are going to see lines printed to the console. After our build succeeds, we'll be able to see the text pop up in the console. We just have to wait for the whole app to load. Your simulator could possibly load as well. In fact, it most likely will, but we didn't really put anything to be displayed on our app, so your app will be blank. The results instead will show up in the console. Let's just wait for the app to load and the console to appear. Because we started a brand new project, you can see it launched for a while and then it finally ran. And because it's our first run of this new project, it can take a while. But look, here we finally got some text in the console. We don't really need the simulator, we can go back to Xcode. If I pull up my console, I can see all the text there. Once upon a time, there was a student watching a CoreML course. They went on to do great things. Alright, so this has tokenized our text. We now have each word being an individual token printed out. And that is all thanks to this Enumerate Tokens, which took our machine learning models. Our machine learning model, we just have one here. It took the model and it enumerated the tokens created by the model. Alright, that is our result. And this proves that we have been able to successfully launch, instantiate, and run a natural language tokenizer model. You can see here Xcode has very powerful machine learning models. We barely had to write any code and we already have such a powerful model running. Join me in the next lecture where we are going to continue learning about yet another machine learning model that we can instantly use here in Xcode. I will see you in the next lecture to start another project. Hello everyone and welcome back to our CoreML course. In this lecture, we're going to build yet another project using one of the powerful machine learning models, part of the natural language framework of CoreML. For this, let's make a brand new Xcode project once again. It's going to be an app and it is going to be called Identify Parts of Speech. That's right, we can actually very quickly build an app that can identify parts of speech in a text. Like this is the subject, the predicate, noun, verb, adjective, and more. You'll see. Let's go ahead and click Next and save this project to a folder on our computers. And this is going to launch our project. Great. We can hide the right sidebar and let's open up viewcontroller.swift. This is where we're going to write the code for our app as per usual. In here, we have to import natural language. That is the framework we're using. Natural language is one framework part of CoreML. And let's get started with building a machine learning model that can tag parts of speech. This machine learning model is known as the Nl Tagger. Nl Tagger, there it is. It's a pre-built Xcode machine learning model that we are free to use. We have to pass in a tag schemes property. For our tag schemes, it's going to be the lexical class. Lexical class means the part of speech. All right, and let's save this new instantiation of an NL Tagger object. We are going to call it a tagger. This means we are now free to use the tagger constant as a machine learning model. Now, for tagging parts of speech, what do we obviously need? Well, we need some speech. So let's make text that we're going to tag. For this, I'll make a text constant and I'm going to say the CoreML student studied a course and published a machine learning app. All right, here we have a piece of text, and we're going to tag the different parts of speech in the sentence using Nl Tagger. Quite a powerful machine learning model. And it doesn't even take many lines of code. The first step is going to be to set the tagger's string property. The tagger needs to know, what am I tagging? The tagger is going to tag the text. So that is why we set the tagger.string to equal text. The tagger also has options, which means we can fix and manipulate the text in order to filter it and process it. For this, let's make a constant we'll call options, and options. We're going to use Nl Tagger.options. So the Nl Tagger class, it has this options property that we can set. For example, we could omit punctuation, and we could omit white space. This means that we're going to be cleaning up our text. We are going to remove the punctuation and remove the white space. And we'll store those options as an options constant. Next up, we can take the tagger and enumerate tags. This means we're going to be able to iterate through every tag that the natural language tagger created. For the arguments of this enumerate tags, let's pass in text.startIndex, which is where we begin the enumeration, all the way up to text.endIndex, which is where we end the enumeration. Now, every unit still inside the arguments, the argument unit is going to be a word because we are tagging words. The scheme is going to be lexical class. This is a scheme that classifies tokens according to a class. The class can be part of speech, punctuation, or white space. Now, we're going to be, of course, focusing on part of speech as the lexical class because we don't need punctuation or white space at this time, but of course you could build an app that does that as well. We also want to pass in the options for our enumerate tags arguments. The options is going to be our options constant. That means we're going to apply this processing of the text to the tagger. Following that, we use curly brackets to open up the body of the enumeration. And what we're going to do inside of the body here is take a tag and token range, and we are going to check if the tag is equal to tag. Then let's make a result, and the result is going to be \text at the token range and \tag.raw value. So what is this printing out? Well, this is going to show us every word in our text and also its associated tag. It's part of speech. And now that we have our result, and remember we have the result for every token, every word, because we're using this enumeration, and at every result we're going to print the result, and this will give us a whole list of words and their part of speech. You can see here we're missing a return in a closure because we have to add return true in this closure. And that is going to clear the message. And just like that, this is all we need in order to instantiate and put to use a natural language tagger. Let's go ahead and test out this project. We're going to see our text now, but we're going to see all the words and their part of speech. To see this, because we're using the print statement, we are going to have to go up to View and Debug area and click Activate Console. This is going to allow us to see our result printed in the console. Following that, we can go ahead and hit Run. The simulator is not important for this project because we're just demonstrating and focusing really on the machine learning model's power. So we're not focusing on building the app at the moment, focusing more on the power of the machine learning model, which you can then put into any app. So I'm going to wait for my app to launch and attach and now run. And here it is running. I can just open up my simulator here to show you that it's currently running. There it is. The simulator won't show anything because we didn't build any labels for the simulator, and that's fine. We can go back to Xcode here. We can close the simulator, and I want to go back to Xcode. And we can see here, let's see, looks like I'll have to rerun it because I closed it. Okay, that's fine. Just rerun it, and it should run faster on the second time around. If you close it accidentally, just rerun it. I'm going to exit full screen mode. That was the issue here. And pull up my simulator again. So you can see here right now my app is launching. We can see that in the header. Now it's attaching to the simulator iPod Touch. And look, now in our console we can see a result. The simulator is empty because we didn't put any text into it. But here in our console is where we have our result here. We can see we now have all of the words and their associated part of speech. Look at this. First off, we have the. The is a determiner. After that, we have CoreML. CoreML is a noun. Following that, we have student, also a noun, and studied, a verb. So you can see here the machine learning model is accurate at tagging a part of speech in our text. We can check how accurate it is. After studied, we have a determinator, course, a noun, and a conjunction. Published, a verb, a determiner, machine, a noun, learning, a verb, and app, a noun. So machine learning together is actually a noun. So this is the one part where the model wasn't 100% accurate because machine learning together is a noun instead of being two separate noun and verb. But other than that, the model was extremely accurate at tagging parts of speech in text. That is incredible power considering how few lines of code we wrote. And this is all thanks to the natural language framework, which has many machine learning models we can use just like that. Alright, join me in the next lecture. We're going to look at yet another natural language machine learning model to help expose you to the power that you can put into your applications. I hope to see you in the next lecture. Hello everyone, and welcome back to our CoreML course. In this lecture, we're going to build another project with a natural language CoreML machine learning model, and that is going to be a machine learning model that can identify places, organizations, and people inside of a string of text. To get started, let's go to Xcode and make a brand new project here. We'll go to File, New Project, and it's going to be an app. Let's call this Identify People, Places, Organizations. Then we'll click Next and we'll save and create this new project. Alright, let's go to viewcontroller.swift where we are going to write out the code for this project. In the viewDidLoad function is where we are going to write the main functionality. To use the natural language machine learning models, as always, we have to import natural language. Then in viewDidLoad, let's go ahead and instantiate a new natural language model. First off, in order to find people, places, and organizations in a string of text, we have to use the Nl Tagger model. And we're going to set the tag schemes this time to be the natural language tag scheme known as name type. This is going to allow us to build a new machine learning model instantly called Nl Tagger, and it's going to be able to identify words by their name type. Let's save this machine learning model as the variable constant tagger. Next up, we have to assign some text for the model to work on. Let's make a constant called text, and we'll put in some text that contains people, organizations, and places. And then we'll run our tagger after writing out more functionality. We'll run our tagger on the text to see how well can the tagger identify people, places, and organizations. So for our text, we can write some string like the American Cancer Society was founded in New York City, New York. This is just some research I did earlier on a string that we could use that has people, places, and locations. Its Nobel Prize laureates include James D. Watson, Mario Capecchi, Oliver Smithies, Paul Berg, E. Donald Thomas, and Walter Gilbert. All right, here is our string of text. Now let's take our tagger, our machine learning model, and let's assign its string property to equal that text. That means the model is going to train and test. To be more specific, it's going to do the performance on the text because it's already been trained by Xcode. Next up, let's make a constant called options. This is going to allow us to process the text. To make options, we're going to use Nl Tagger.options. You can see here options provides constant for linguistic tagger enumeration, specifying what to omit, and whether to join names. So this allows us to process our text. For example, you can omit punctuation, you can omit white space, and you can join names. That means any names that appear will be joined if they are recognized by the tagger as names. Next, we have to actually specify the tags. Let's make a constant called tags, and it's going to be an NL tag type. This is a token type, and we are going to set it to 3 different types, an array of 3 types. First, a personal name. This is an NL tag type, and it indicates that a token is a person's name. Then we can have place name. This is a keyword for the NL tag of a location name like New York. And there's also organization name. This is a natural language tag that can find an organization in a piece of text. All right, now that we have our 3 tags set up, let's loop through each of our tags in our text, and let's actually tag it with personal name, place name, and organization name. For that, we will call tagger.enumerate tags. Enumerate tags means we're going to loop through all of the tags that our tagger found. And for the arguments here, let's start with the in argument. The in argument is going to be our text.startIndex all the way up to our text.endIndex. Following that, our unit type is going to be a word. Our scheme is going to be name type. And our options will be the options that we created earlier and stored in a constant. Then let's use curly brackets to open up the body of the enumeration here. And we'll say for each tag and token range in our enumeration, we are going to use a loop if tag is equal to tag, and as well tags contains a tag of that tag. That means we found a word that can be tagged. And let me just return true to remove the missing return message. Alright, so if we find a tag that is a person name, place name, or organization name, that means we have a valid tag that our machine learning model found. And in that case, we can print out the text at the token range. And we can also not only show the text, which is the word, but also the tag.raw value. This means we're showing the text, the word, and then the tag, which is the person, place, or organization. Which of those three tags is it? All right, and let's see. Following our if keyword here, we can also actually add a hypothesis result. So this means we can actually show the confidence of the machine learning model. The machine learning model is going to say, for example, starting at American Cancer Society. If it finds American Cancer Society, it's going to detect that is the first phrase in the text that is a valid tag because it's an organization name tag. And so it's going to tag it with organization name, but it's also going to have a confidence score. For example, I'm 100% confident that that is an organization name, or I'm 90% confident that that is an organization name. And we can actually show the confidence of the machine learning model for every valid tag it finds. To do that, let's add some more functionality at the end of our function here. It's going to be above the return statement, of course, because the return statement will exit. So we're going to make a constant called hypotheses, and we are going to also get the tagger and use the tag hypotheses function. Tag hypotheses, that is a function of our natural language tagger class, and what it can do is it can show us the confidence score. So we'll say at the token range dot lower bound, the range is lower bound, the unit will be the word, and the scheme will be the name type. The maximum count can be 1, and let's print out the hypotheses. So we're going to show the confidence score of our machine learning model. And we also want to ensure this is in our enumeration because we want to show it for every valid tag the model comes across. And just like that, this is all we need to build a tagger. Let's go ahead and test out our code. For this, I'm going to go to View, Debug Area, Activate Console. That way we can see our print statements. Then I'm going to hit the big Run button, and that is going to build my app. Because this is our first time building a brand new app instance of this app, it may take some time to launch the app, but we saw the message build succeeded, which means currently my preview is being run in my simulator here. And it's just loading now because it's the first time we're launching this current app. And here it goes. The app is launching, and the app itself doesn't have any content, but that is fine because we're just focusing on the core ML topics, which we could include in any app. And look at this, if we go back to Xcode, we can now see some content in our console because our app loaded enough. If we go to the very top of the console, we can see we start with other word with 100% confidence. Then we see American Cancer Society being tagged as organization name. And the confidence score is 100% of organization name. Following that, we have other word, other word, other word, which is 3 other words, which is going to be was founded in. Those are 3 other words that are also almost 100% confident. Then we have the next word, New York City. That has been tagged as a place name. And the place name confidence score is 100%, quite high. Then we have New York, the state, which has also been tagged as a place name, and the confidence is 100%. Following New York State, we have other word, which refers to its, because our model is going to go word by word. After that, we have Nobel, which has been tagged as a personal name, which is correct because the Nobel Prize was named after Alfred Nobel. Then we have personal name following that with a confidence score of 100%, which is Nobel. Those are both the same. But then we have 3 other words, which just refers to any word that is not a person, place, or organization. And those are laureates include, and prize as well. Prize laureates include. Then we have James, which has been tagged as a place name, which is where our machine learning model is not 100% accurate because its confidence in that was 100%, but James here, it refers to a person name, not a place name. Then D was other word. So it looks like the model is not optimized for unique situations where we also include the middle initial of a person. And that's an edge case that is important to be aware of. Following that, we have Watson, which again is a place name because James and Watson, they were separated by that middle initial. Following that, we have Mario Capecci. Now this has been tagged as a personal name because our word joiner, which we set in our options, remember in options we set to join words, join names to be specific. And so because we no longer have a middle initial, our join names, which is part of our machine learning model, it was able to successfully join the personal name. And that allowed it to also tag the name correctly. And then we have another personal name mixed with other words as well. So the confidence score of our model is quite high. It's nearly 100% for every single word that it comes across. And our model was almost 100% accurate as well. So that is quite high accuracy for a machine learning model that we quickly managed to load in here in our Xcode project. And that just goes to show you the power of these natural language core ML models. All right, that does it for our project on identifying people, places, and organizations. Don't forget to find all the source code at the end of every section. And coming up in our next lecture, we're going to start yet another project, continuing our look at the powerful core ML models. Hello everyone, and welcome back to our core ML course. Our next project together is going to be to build out the functionality so that we can detect similar words and sentences. We're actually going to be able to use machine learning to find similarities among text. Now, in order to actually be able to process text and find similarities between text, we have to understand the concept of word embedding. This is very important for machine learning on language. So let's learn in this lecture what is word embedding. All right. What is word embedding? Word embedding is a text distribution representation. It is a way to represent text data. We have to embed text in order for machine learning models to be able to understand words. With word embedding, if a word has a similar meaning, then it'll have a similar representation. And same with a sentence. If a sentence has a similar meaning, it will have a similar representation. Because a machine learning model, it cannot understand text, but it can understand numbers. So what we do is we actually convert words into numbers. And you may be thinking, how do we make a word into a number? Well, we use what is known as a vector or an array. And this way we can represent a word as a sequence of numbers. And similar words like dog and dogs, because those words are so similar, they will have a similar numerical vectorized representation. Then if we plot the words, then the words will also be close by in location. So if we had a bunch of words on a graph and we're representing them numerically, words that are similar in meaning should be closer to each other on our plotted representation or graphical representation. For example, here we can see that boy, man, and son, they are all similar in meaning. That's why they're all closer together in this graphical representation. First, the steps to word embedding is to convert a string to numbers. That's known as text vectorization. We vectorize a string. Then, once the text has been converted into this numerical format, because machine learning can understand and perform math, now we can do machine learning on the text. Let me use a very simple visual examples to help you understand. Let's say we had 3 words that we need to vectorize and process. Those words are puppy, dog, and cat. Puppy and dog, they are more similar to each other than puppy and cat. That's why puppy and dog, they should be more similar in their numerical vectorized representations. We can see here in this very simplified visual representation. Puppy, dog, and cat, they all share an orange square. And the squares here, they represent numbers in our vector. We here have an array of colors, and we're just using colors instead of numbers to make this more visual. So puppy, dog, and cat, they each share an orange square, meaning they would share one number in their vectorized representation. Puppy and dog, they also share a green square, whereas cat does not have a green square. And that could be because puppy and dog are both part of the canine family, so they should be more closely related with that green square, and cat should be excluded. Sorry, cat. You'll also notice that dog and cat, they share a red square, and puppy is excluded because puppy has a blue square. And we go index by index, by the way. We go index 0, that first column, index 1, that second column, and index 2, that third column. And at that third column, puppy is excluded because it has a blue square, whereas dog and cat, they have a red square. That means that dog and cat are somehow more related than puppy. And that could be because dog and cat are adult animal names, whereas puppy is a baby animal name. So we can see here that puppy is closer to dog and dog is closer to cat than puppy is closer to cat. If we plotted these 3 words on a graph, well, puppy and dog should be close to each other, and then cat should be close to dog but not close to puppy. So this is a visual simplified representation of how you can convert words into vectorized representations. Because now each word is an array. And although we're using an array of colors, in actuality it would be an array of numbers, and each color is a shared number. Now here is a more complicated example, because with vectorization, we typically wouldn't have just a 3 length array. We would have longer arrays to represent each word. So now it's a bit more complicated to see the similarities between puppy, dog, and cat, but we can still see that puppy and dog look more similar than cat, because cat has a lot of pink, whereas puppy and dog, they both have greens, and that therefore they look more similar. So this is a bit more realistic because we're using way more colors here to represent each word. If we just used 3 colors for each word, we would quickly have a hard time making a big vocabulary. That's why we have longer arrays to represent one word. That way we can have a bigger vocabulary with more words and more complicated associations and similarities. And that is word embedding. In this lecture, you learned that word embedding is very important for machine learning because it is how machine learning can understand text. Now, coming up, we're actually going to be building a project where we use word embedding, and we're going to use word embedding to find similarities in text. We can actually quantify how close words are to each other on a graph with a number. Like dog and puppy are 2 points away, whereas cat and puppy are 5 units away. We're going to be jumping into Xcode and coding out a project using word embedding. I hope to see you in the next lecture.
Hey everyone, thanks for watching this course. If you want to watch the rest of the course, the link is down below. Not only will you get the access to this course, but you'll get access to a lot of other courses in a huge bundle, and it's on sale today. So buy before the sale ends. Thanks for watching, and I'll see you in another video.